In this video, we are going to be studying the empirical rule, which is also known as the 68-95-99.7 rule. The empirical rule can only be used on data that is distributed normally, that is data that is distributed symmetrically. So when you're looking at the histogram for this data, it should look symmetric. If you were to add a curve over the histogram, you would see a bell-shaped, a mound shape, kind of like these two shapes that we have up here. So what the empirical rule states is that for data that is symmetrically distributed, normally distributed, at least 68% of the data will be within one standard deviation of the mean. So remember, the mean is in the middle, saying that if you subtract one standard deviation from the mean and you add one standard deviation to the mean, 68% of that data is going to fall between those two values. It says that at least 95% of the data will be within two standard deviations of the mean. So if you were to subtract two standard deviations from the mean and add two standard deviations from the mean, at least 95% of that data is going to fall between those two values. If we continue to go on, the empirical rule says that at least 99.7% of the data will be within three standard deviations of the mean. So if we subtract three standard deviations from the mean and add three standard deviations, we will have at least 99.7% of the data between those two values. Now let's look at an example to see how we use the empirical rule. It reads here that heights of men are normally distributed with a mean of 69 inches and a standard deviation of 3 inches. In this sentence, it tells us that it is normally distributed. Because it says normally distributed, that means that we can use the empirical rule. If it didn't say anything about the data being normally distributed or symmetrically distributed, we wouldn't be able to use the empirical rule. It also does not mention anything about taking a sample of these men. If it does not say anything about a sample, then we are to assume that we are dealing with population data here. And so since we are dealing with population data, this 69 inches is our mu. Mu is the population mean. So that's our population mean here, this 69 inches. Standard deviation of 3 inches, so that represents our sigma. Sigma is the population standard deviation. So we have that mu is equal to 69 and that sigma is equal to 3. So now we can go up back top to our empirical rule table and start filling in some of this data. The empirical rule states that at least 68% of the data will be within one standard deviation of the mean. Within one standard deviation of the mean, so we need to take our mean, which is 69, and subtract one standard deviation. 69 minus 3 gives us 66. 2. And then we also need to add one standard deviation. 69 plus 3 gives us 72. So we have that at least 68% of the data will be falling between 66 and 72. That's why here in this bell chart here, I have my mu in the middle. That 69 represents the mean. I have subtracted one standard deviation to take me to 66 and added one standard deviation to take me to 72. Now, if 68% of the data falls between the 66 and the 72, and this data is symmetrically distributed, that means that the piece between the 66 and the 69 must be the same size as the piece between the 69 and the 72. So I'm going to split this 68 degrees, the 68% into two pieces to have 34% and 34% of the data there. And we'll see how we use that later. Now continuing, let's find the bounds for where 95% of the data will be. So we need to take our mean, 69, and subtract two standard deviations. So this time I'll be subtracting 6, and 69 minus 6 is 63. And then I will also be adding 6, because I need to add two standard deviations. And 69 plus 6 gives us a 75. You see up here, I have 63 here and 75 here. 98% of the data falls between these four rectangles, between the 63 and the 75. Now we already have 68% of that data between the 66 and the 72. Between the 66 and the 72, we already have 68% of that data. So to figure out how much is between the 63 and the 75, we will do 95 and subtract 68. 95 minus 68 gives us 27. And then I will divide that 27 by 2 to split that up between here. So there's 13.5% of the data there and 13.5% of the data there. And I got that 13.5 by doing 27 divided by 2. Moving on to where 99.7% of the data lives, I need to now subtract 3 standard deviations. So I'm looking at 69 minus 9. 69 minus 9 gives us 60. And then we will add 3 standard deviations. 69 plus 9 gives us 78. So 99.7% of the data lies between 60 and 78. Doing that same similar math to figure out how much lies between 60 and 63 and 75 and 78, we get 2.35% of the data in there. 2.35% of the data. If you were to add all these up, all these percentages, it needs to sum up to 100%. And we would see that we're missing 0.3%, so there is 0.15 in that piece off to the left, and there is 0.15 in this piece off to the right. That's what the percentage of the data lies in those ends. And these numbers are true not only for this example, but these numbers are true for any data that is normally or symmetrically distributed. So question A reads, what percent of men have heights between 66 and 72 inches? Well, we have that right here from just going within one standard deviation of the mean. Between 66 and 72 inches, there must be at least 68% of the data there. There could be a little bit more, but the empirical rule says that at least 68% of the data must be between one standard deviation of the mean. 66 and 72 are within one standard deviation of the mean. Question B reads, what percent of men have heights between 60 inches and 78 inches? Well, we can see that by going within 3 standard deviations of the mean. Between 60 inches and 78 inches, we have 99.7% of the data, at least 99.7% of the data. So that is our answer to part B. At least 99.7% of these men have heights between 60 inches and 78 inches. Part C reads, what percent of men have heights greater than 75 inches? Greater than 75 inches, so we can't just look in the table here and pick that answer off like we did for part A and part B. So let's go look at our Bell distribution that we have here. We want to know how many men, what percentage of men have heights greater than 75 inches. So here's 75 inches right here. And I'm looking for heights that are greater than that. So I'm going to add these two percentages, this 2.35 and this 0.15. I'm going to add those two together to see what percentage of men have heights that are greater than 75. So summing that up, we have 2.35% plus 0.15%. And that gives us 2.5%. Now, it might be a little bit more than that, but by the empirical rule, we can definitely say that at least 2.5% of men have heights that are greater than 75 inches. Question D reads, what percent of men have heights between 66 inches and 75 inches? So going back up and looking here, we're looking for everything between 66 and 75. So between 66 and 75, there is our 66, everything to the right of this, but everything to the left of 75. So we will be adding up 34%, 34%, and 13.5% to get our answer for that question. So we have 34% plus 34% plus 13.5%, and that gives us 81.5%. So at least 81.5% of the men have heights between 66 and 75 inches. Question E reads, between what heights can you guarantee at least 95% of the men's heights fall? So we want to know what we can say about 95%. Well, we could pick that off right here from this second row in this table. At least 95% of these men will be between 63 inches and 75 inches. So that is our answer for part E. And those are some examples of how we use the empirical rule.